your attention for the next pitch from IC SensUs from England.
Hello everyone, my name is Katya and this is Akash, and today we're going to represent Imperial College London from London, obviously, and we'll present to you our biosensor that we have been developing. So just to give you a bit of a background, obviously heart failure is the disease that is a global contributor to the global mortality rate, with approximately 20 million people dying of heart failure related diseases annually. And to be able to detect this disease early on has shown that it would allow us to use therapy to improve the life expectancy and lifestyle of patients to almost near normal. Therefore, it's very crucial to be able to detect the biomarker for it, which is NT-proBNP, with ultrasensitive device, and also to make it implementable in different countries so that worldwide we're able to tackle this issue. And we have been working on the biosensor that is implementing the use of magnetic microparticles. And the general workflow is this. So first we would use the blood sample and insert it into a flow cell that Akash has right here. It fits on the palm of your hand, so it's very small, and it's also 3D printed and therefore can be used at home. And then we would image one of the filters that is fit inside this flow cell in one of these slots. And we would produce an image using a USB microscope, which is just £20 off Amazon and can be literally connected to your home laptop. And then we would use the algorithm that we have developed using a software image day that would quantify NT-proBNP. So how exactly does our sensor work? So this is the method of detection. Within the flow cell, we have 3 different layers. The first layer is the fiberglass membrane. This fiberglass membrane would contain antibodies that are functionalized with magnetic microparticles. The functionalization occurs using biotin-avidin interaction, and these antibodies are just covering the surface, but they're not attached to the surface. Therefore, when we add the blood sample onto it, the antigen that is NT-proBNP would bind to the antibody and therefore form the antibody-antigen complex. Then the earth magnet at the bottom of our flow cell would pull the magnetic microparticles down onto the next layer, which is nitrocellulose membrane with 1 micron size pores. These pores are large enough for the unbound antibodies to pass through and be collected onto the second nitrocellulose membrane that has very small pores and therefore is used as a filter. All of the other antibody-antigen complexes would be immobilized onto nitrocellulose membrane with larger pores due to the fact that there is capture antibodies present on that surface. That would allow us to form the kind of sandwich assay there, and we would have 2 antibodies and they would surround 1 antigen. And therefore we can remove this nitrocellulose membrane and then image it using the microscope. This allows the device to be reusable, and the only thing you need to purchase is just the flow cell to begin with, and then different membranes can be removed and visualized. So why does our device work well, and why do we think it's good for the public? It's because it can be used anywhere. It's very low cost. Everything here is pretty much 3D printed, and also the camera is very cheap, and with the advances in technology, we will soon be able to just image it using our phone. The software that we would be using would be able to see the individual microparticles due to the properties of the magnetic particles to scatter light and appear black. And this software could be easily implemented on your phone and just used as an app. And also, it's really important due to the fact that a lot of the laboratory procedures here can be used anywhere in the world because the avidin-biotin interaction is very easily done in any lab. So this is our sensor, and we hope to be able to use it in marketing as well due to the fact that sandwich assays have been previously used already in SensUs, and that streamlines the FDA approval. And also due to the fact that this is quite an easy method of detection that can be used anywhere in the world. Thank you very much for your attention, and I will take questions if you have some. Thank you. Any questions? Thank you very much, guys. We're just at the stall over there if you have any further questions or want to know more about the device. Thanks.